Eric explained the approach he took and the results he got from his thesis topic, which is to optimize the ODU maglev system ridership performance. I'd like to say a word or two about that. This problem turned out to be very much like problems that you run across when you're actually out working for a living. That in most cases, when you try to optimize something, you have the inputs, you have a model you develop, and you have figures of merit or objective function that you look at to try to optimize. In this particular case, Eric had to develop the model of the system to enable the work to be done. But also in this case, the inputs were unknown, as is often the case in industry. Professors in the School of Business did an excellent job of developing information about the input that of people attending class. But in this case, we also needed information about off-peak ridership, people attending special events such as basketball games, and even meal times. And finally, in this particular case, the figures of merit that you would use in optimizing the system were unknown. There are a lot of figures of merit for transportation systems, but in this case, the transportation system that's competing with the maglev is walking. Okay, so some of the figure of merits that you would normally use really wouldn't be useful in this case, and Eric had to make up a lot of them himself. So you might be looking for that as we go through the talk. So without further ado, I turn it over to Eric.
Thank you very much, sir.
Also, I think that it's, as is, I think normally the process here, we ask questions as we go.
It's allowed, but typically we have a session afterwards. I mean,
Okay.
time allotted.
So if you have questions about just clarification of what's going on, we'll ask them during the talk so people don't get lost, but we'll hold the don't understand this and why did you do that questions until later. Okay, Eric?
Thank you very much, sir. Dr. Green, Dr. Richard, Dr. Alberts, Dr. Newman, Dr. Cesara, classmates, friends, good afternoon. This afternoon, my task is to describe to you the research that I did entitled Optimization of the ODU maglev System Ridership Performance. Maglev technology has been around for a century, and the maglev technology is used for maglev trains, and it's projected as the best candidate for future public transportation. Interest in it has waned, and during the 1950s, due to problems in costs and due to railroad costs. So, and it has seen its resurgence in the past 20 years. But still the challenge remains on how to make the system cost effective. To make it cost effective, my research is focuses on how to optimize the system, because when we optimize the system, cost effectiveness is automatically obtained. How do I go about optimizing the system? I have here my research objectives. For a maglev system, I need the number of sleds or the train itself. I need to know the capacity of each sled. I need to know the mode of operation. What is the pattern of movement of the sleds? And do I modify something in the current infrastructure? Do I add parking areas? And this I need to do by considering the performance metrics and the vehicle cost, acquiring the vehicle and operational costs. So this afternoon, I've already introduced and my research objectives were already identified. I will give you a sense of what the system inputs are, what is my ridership demand, modes of operation, figures of merit, simulation, then I'll discuss the results and analysis, form a conclusion, and then discuss some possible future work. Everyone has seen the ODU maglev track. This is just this chart shows the length of the whole track. From the 39th pier, that station is actually known as 39th pier, but for ease of memorization, I call it TED Center. And the web station is at the center, which has been turned down, and Powhatan is at the other end. So these are the track lengths, as you can see. And one of the things I have to do is, from that infrastructure, I had to model it in a software. I used Arena, discrete event simulation. And you can see one of the snapshots that I made for a certain type of mode. As you can see, there are 2 sleds, passengers entering this web station, passengers exiting, and that is how it looks. Now, to get a better sense immediately of what what has been done in this research, I'll give you a short 2-minute video presentation of what has been done. Full screen. So, as you can see, 2 sleds are going back and forth. The station. This is double shuttle asynchronous. But just focus on the movement of the sleds, the arrival of the passengers, and the exit of the passengers. And this is another pattern of movement. It's called double shuttle synchronous, which I will be discussing in a little while. You can see the passengers, 2 sleds converging at the center, and in a synchronous fashion, this one has to wait, and it will leave the station at the same time. This is another mode that's called the double elevator mode. Notice that the first 2 animations, the 2 modes are constantly moving. This one, there's no passenger at the left-hand side, at the station pair. For the right-hand side, it still moves. It depends if there are passengers arriving. Now, this is a 3D shuttle animation that I made for this research. So as you can see, ODU, you have passengers coming from TED. This is Hampton Boulevard. This is the whole maglev track, 1,000 meters approximately. And you can see the buildings, web center, and people, after riding the trains, they proceed to their respective classes. This is during class peak or class times. So there are passengers here who were not able to make it to the train, so they just opted to walk, and they just went straight to their respective buildings. So this is a close-up view of the passengers. And I just like to show a more detailed view of the maglev. So some more animation there. So the passengers coming from TED will are proceeding to the web station, and still getting more passengers. Waits for some 20 seconds, goes back to web station. So this is how it's going to look like. If the our transportation system is fully operational.